So we're starting off today's session with the SOSA Consortium overview presented by the SOSA Consortium Steering Committee Vice Chair, Nick Borton. The Sensor Open Systems Architecture is a major standard in the United States Department of Defense's Modular Open System Approach Initiative. And in this presentation, you'll hear an overview about the SOSA Consortium and the technical standard from Nicholas. Nicholas Borton is a principal embedded engineer and machine intelligence architect at SRC Incorporated, with 20 years of experience in digital hardware design, embedded processors, heterogeneous compute, and low-level bare metal software design. In this role, he is responsible for the technology direction of the group and maintaining commonality across the programs that the group is executing. Nick, over to you.
I'm happy to be here to be able to talk about the Sensor Open Systems Architecture Technical as well as the consortium makeup. And I'm hoping that after this overview, the audience will be able to have a better understanding of what SOSA is all about. So the SOSA approach in a nutshell. The SOSA Consortium is a technical and business collaborative effort. We're working on creating a open systems architecture for radar, EOIR, SIGINT, EW communications, and directed energy weapons systems. And along with that, the various business models that are going to be able to drive a thriving market into the future. We're doing this to be able to improve various systems, subsystems, affordability, upgradability, reuse, really with the main goal of shortening cycle times to be able to get stuff out into the front lines quicker and faster, hopefully being able to save the war fighters' lives better and faster. We have participation from the Air Force, Navy, Army, and other government agencies such as NASA. We have a wide swath of industry. I think we're in the neighborhood of north of 170 member organizations at this point. And we have a little bit of academia participating. So we're going to get this architecture through modular decomposition, so defining functions and behaviors, as well as the associated interfaces including physical aspects, protocol, data structures between those various modules. So a modular open systems approach. So the intent here is to have an integrated business and technical strategy to be able to have competitive and affordable systems over the whole life cycle from acquisition to sustainment. So in order for this to work, we have to have both the business side, which often includes contracting language, intellectual property, the means by which various piece parts of systems are going to be acquired and upgraded over time, as well as partnering with the technical side, which defines the modularity and then all the various details that go into the open systems architectures themselves. Some of these open systems, such as OMS, SOSA, FACE, Victory, are relatively well known, but there are many others that continue to pop up through the DoD's continued push towards MOSA. Another important aspect is that all of these architectures need to be subject to a conformance verification and certification program in order to meet the full tenets of MOSA. All right, so what do modular and open mean in this particular context? So for modular, what we have are encapsulated functionality and behaviors with well-defined interfaces, or stated in another fashion, we have tight integration and cohesion within modules, and then those modules are loosely coupled with other modules. Openness has 3 criteria here. First of which is widely available published definitions. Unfortunately, oftentimes this is where things tend to stop. And while this is necessary, it is not sufficient to meet the MOSA tenets. You also need to be able to have a consensus-based and documented governance process that enables any stakeholder that wants to be able to participate to be able to influence and affect the development and course of action that the standard actually takes. And that's something that the SOSA Consortium provides to this organization under the stewardship of the Open Group. And the last tenet of openness is that there is a conformance verification and certification process to ensure that there's honesty in the market and that everyone truly is playing on an even field. All right, so how are we going to achieve much of this that we're looking for in SOSA? A lot of the aspects as we're working through this in the consortium that's getting added into the standard are measured against our quality attributes. So we have the first 5 of our 10 quality attributes on the screen now: interoperability, securability, modularity, compatibility, portability, plug and play ability, upgradability, scalability in 2 forms, both sensor multiplicity and the platform size that the system is attached to, and resiliency. These have been kind of the, I'll say, guiding goalposts that we measure all the various content that goes into the standard against. On top of the quality attributes, we also have the architecture principles, 15 of which in total, 3 that are business oriented, and the remaining 12 are technically oriented. For each one of these, on top of the actual name, there's a thorough statement, rationale for why it was included, and the implications for the standard if we adhere to these principles as we continue to develop SOSA. All of these quality attributes and architecture principles have been in the released SOSA technical standard for quite some time now. So I suggest people who are interested to download the standard and read these sections. So beyond all of this, we also have an overall approach of leveraging existing standards. This graphic depicts how we have standards from across the DoD and industry all feeding into the SOSA technical standard. One particular standard in general that we have an awful lot of cohesion with is the VITA family of standards. And in here we have a couple of different examples of the way SOSA will include standards into our larger architecture. And it signifies the adopt before adapt before invention mentality. So some of the VITA standards we take as a whole, and then we expand upon them in order to meet our various needs. Then there are other standards from VITA which we have taken a subsection and narrowed down to just core components that we're looking to include within SOSA. So that way we can meet our various quality attributes and architecture principles. The SOSA Consortium is organized into a relatively simple hierarchy. Up at the top, we have the steering committee, which provides the general guidance for the rest of the consortium. So that is included of representatives from all those who join the organization at that level. Underneath the steering committee, we have the business working group and the technical working group that follows the 2 halves of the MOSA breakdown. And then in between those, we have the Architecture Standing Committee and the Conformance Standing Committee, which help support and also ensure the cohesion between the business side and the technical side. So at the steering committee, business working group, and technical working group level, the chairs for those committees are elected by the steering committee. And then all the rest of the chairs, co-chairs, and leads are appointed by either steering, business, or technical working groups. Now, that being said, any member organization within SOSA can be a chair for any of the groups other than steering. And the other thing I will point out is that when we're doing votes within the SOSA Consortium, regardless of what level you're at and whether or not you have a leadership position or not, every organization has 1 equal vote into what is included into our standards and our various documents. All right, next I'll start diving into some more of the details of the actual technical architecture itself. So before I start really getting into those details, I kind of want to show some of the mentality in terms of what it means to be building with the SOSA technical standard. So what SOSA provides is a set of tools with which everybody's able to use to build a system or various products. And the various system designers and architects choose what tools to use. So there isn't anything mandated in the SOSA technical standard itself as far as what you must or must not include. A corollary to this is that systems are built with SOSA components, but very importantly, systems are not SOSA in and of themselves. It's just that systems, hopefully that are in tight alignment with SOSA, are going to have more components, more interfaces that are called out in the SOSA technical architecture. All right, so how do we get these interfaces to build with? So as I said before, all of our various SOSA tools, right? So all of the modules that we were decomposing, all the other piece parts that we have are based on standard interfaces. Interfaces include physical components, protocol components, and the various signals or data that you're trying to convey. Some of the various piece parts in SOSA has the functions and behaviors that comes with the data component. Other areas contain the physical interfaces, and yet other areas of SOSA discuss the APIs or communications protocols between all of these different components. SOSA has a wide variety of interfaces that are able to serve different purposes, but all of them enable us to be able to speed integrating capabilities together, enable severability between hardware and capabilities, and create an ability to upgrade and have mobility of hardware and capabilities between different systems. So in the end, we have to make sure that when you're using the SOSA architecture, that all of the interface choices are very deliberate and meet your very specific goals. All right, so on to the actual piece parts in the technical standard. So our taxonomy diagram depicted here shows all the breakdown from a SOSA sensor component all the way down through the trees to the various higher level structures that we define within SOSA. Each of these leaf blocks essentially represents a set of interface rules, and these various rules, depending on what your product is, may be additive together. So you may take rules from this group along with the rules that are required from this group and bring them together in order to actually fully define what your particular product or system actually needs to work. Starting off on the module side, the modules provide the functions and behaviors of our various systems. So they perform the work. They are tactical capability focused. They are implementation agnostic, and they provide the various input and output data structures for our interfaces. SOSA has a large swath of modules currently defined in 3 different tiers. Up at the top, we have our SOSA management modules, our system manager and task manager. Down at the bottom, we have our support system modules that include things like the security, network, time, navigation, power, the host platform interface. And then in the middle, between those two, we have the more mission or data-oriented modules. Starting at the front end of our systems, the orange blocks, the emitter collector and receiver exciter. And as we work our way across, we start to develop higher and higher data products with more and more information baked in as moving through and process that data. On the other side of the SOSA taxonomy, we have our infrastructure. So our infrastructure provides our physical and protocol aspects for our interfaces. This is the area where we're typically dealing with a down select of existing standards. And one way to kind of think of the infrastructure is this is the housing for module implementations. So starting through the various portions of the infrastructure, on the hardware end, we have a large swath of plugin cards that we have adopted through the VITA standards. And here we're taking a chassis level approach where you have a physical chassis that encloses a set of cards that all plug into a backplane that can be interchanged in order to create different behaviors and effects. One of the important things that SOSA ensured through our adoption process is that all the various IOs and IO standards that are utilized in SOSA plugin cards are fully defined to enable full upgradability and interchangeability. We also spearheaded a work towards smaller form factors to be able to work towards either space or small UASs. And currently we're focusing on short VPX, which is a smaller version of 3U. And then we also are working with VITA in terms of specifying VNX as an even smaller form factor. Our electrical mechanical group focuses on the various connectors that are on the outside of these chassis, as well as some of the various mounting provisions that they may employ. Similar to the hardware group, wherever we do have electrical with interfaces with mechanical, all of the various IOs are fully defined in terms of what their function and what their various protocols and electrical capabilities are. On the software side, SOSA chose to have various runtime environments that provide the ability to abstract the hardware that the software is running on. Key point here is that we're enabling software module mobility across different hardware deployments. The various profile choices that SOSA has adopted at this point include FACE, the Future Airborne Capability Environment, containers conforming to the Open Container Initiative, and virtual machines conforming to the Open Virtualization format. And then depending on what goals you may have for your system, we'll probably very quickly narrow down which of those various choices you'll want to make for your particular system. And then the last major area of the SOSA infrastructure are the interaction bindings. So these are very specific technology choices to be able to allow for interchangeability, upgradability, reuse, and portability of all these different capabilities and pieces of hardware between all the different systems that are being built underneath the SOSA banner. All right, now that we're through the major aspects of the technical piece of SOSA, we'll start going through the business approach that we have adopted. The SOSA business operation view, shown in the diagram to the left, has four major components. So starting at the top, we have an acquirer. So this is an organization that's looking to be able to procure something that is conformant to the SOSA technical standard, whether it's to be able to build a subassembly, a larger system, or anything else that may be needed in the SOSA ecosystem. One of the first actions they may take is to search the SOSA registry to see if there's anything that meets the requirements already present that they could actually buy right off the market verbatim. If not, they may have to go to a supplier, which is an organization that would be able to produce one of these different units or capabilities that may get added into the SOSA registry. So the acquirer and the supplier may go through a negotiation, figure out what the requirements are, which portions of SOSA they want to be able to utilize in order to meet the acquirer's goals. And then the supplier would be able to go off and go ahead and actually start building their various units. Now, once a supplier has something that they're hoping to get the conformance stamp for SOSA certification, they would then go into the conformance program. The conformance program has two major components. We have the verification authorities and the certification authority. The open group is the certification authority and is responsible for ensuring that the conformance process has been dutifully followed and all of our artifacts to prove that it has been followed are in place. The various verification authorities that would be part of the SOSA ecosystem would be the ones that actually take those various units from the suppliers and test them against the verification procedures that are outlined by the consortium to ensure that all the various requirements against those items are fully adhered to. And if they are, that particular product would be able to get the SOSA full conformance stamp and then add it into the SOSA registry for others to be able to utilize. Now, there are a whole bunch of different composition strategies that various acquirers may take for their end system. You know, you can have something all the way from as fully conformant as possible, all the way to, well, you're not using SOSA at all for, you know, there are various different reasons, to something in between. The way SOSA is set up and that SOSA does not dictate how a system is actually built, just sets forth the various tools you can use to build your system. You can go everywhere from, you know, fully to not conformant at all, and it's perfectly all right. And also the way SOSA is set up with all of our different modules and infrastructure components, there's many different levels for all to be able to participate into the SOSA marketplace and be able to provide, right, their unique value that their organization provides back to somebody else to be able to help the warfighter, you know, meet their goals. All right, lastly, I'll talk about some of the details of the SOSA conformance program. One key thing to point out is the difference between compliance and conformance. Many of the standards out there are more of a compliance-related program as opposed to conformance. And that usually amounts to the organization that is claiming that they meet something is kind of more or less self-attestation that they are compliant. And they don't necessarily have to prove it through a third party. The conformance program that SOSA is going to be following with the open group has independent verification that fully proves that any product meets the standard to the degree that the SOSA Consortium has laid out. All right, verification and certification. The verification process is there to be able to establish the truth, right? Validate the claims of the people that are bringing SOSA product out into the marketplace. And verification is independently from the open group certification body and independent from the group that's bringing the product forward to be able to prove that the product is truly meeting all the various shells within the SOSA technical standard. Now, the certification process is going to be run by the actual open group itself. There's only one certification authority, and their job is to ensure that all the various T's and C's and I's and T's are dotted and crossed, that the full process was followed through verification and conformance as a whole. So all the various items within the leaf items within the SOSA taxonomy are potential conformable items. And as I said before in the earlier portion of this presentation, that these various items or rule sets can be composed into larger and larger entities or more complex products. All right, from here, I'd like to go through a couple of build examples in terms of how the SOSA technical standard could be utilized in various products. All right, this first set of examples is going to be the usage of SOSA components to instantiate various SOSA modules. So the three modules that I have for this example are going to be a signal or object detector, a receiver exciter, and a storage retrieval manager. All right, starting off with the signal object detector, that particular SOSA module in this example is going to be built using the FACE ecosystem. So this is going to be a software module implemented using the FACE rules. Now, due to the way the FACE ecosystem operates, that pairing alone of particular SOSA items is enough to be a singular product. Now, while it may be a product, in order to have it fully integrate in with a whole system, you also need to pair it with a FACE TSS implementation of some of the SOSA interaction bindings to be able to get the proper interoperability and interchangeability with all the other items within the SOSA system. Next example is going to be a receiver exciter, right? This particular example, since we're dealing with, digitizing analog signals, is going to be a hardware example. So here we have a 3U SOSA plug-in card that it's going to be implemented with. Then that is also going to get paired with a SOSA interaction binding so that the functionality of the receiver exciter implemented on that card is able to communicate with everything else within the SOSA ecosystem. And then that plug-in card is going to have some level of firmware that is running on it. Now, because we don't have a SOSA software runtime environment called out here, while there may actually be software running on that plug-in card, since it's not adhering to those interfaces, it is treated as firmware and is tightly coupled to that hardware. And this whole set of items together could also be another SOSA product. My last example is going to be a storage retrieval manager. All right, so again, since we're storing things and being able to recall them back, we're going to have some more hardware. Likely it's going to be a SOSA plug-in card that's going to house some number of solid state storage drives, perhaps. Now, in this particular case, this example is going to be using a containerized environment in order to implement the various functionality of the storage retrieval manager. Now, this particular example, since it's a container, as long as it's able to talk to the actual storage medium on the hardware, it might be able to house somewhere else in the system, not necessarily on that particular plug-in card. And then since it also needs to be able to talk with everything else in this system, a particular SOSA interaction binding will also be implemented in the interfaces of that container implementation. And then that as a whole is yet another SOSA product. All right, flipping on how SOSA might be used through a different lens. Now we're saying like, all right, instead of individual SOSA module products, how do we take a whole entire system? So we'll say this example, processing chain, and how might we implement that and those various modules onto this hardware set that is also provided to us. So for this particular example, we'll say the emitter collector, so this is the front end interface to the RF environment, is going to be implemented on this set of hardware, which is then going to be cabled into the back end portion of the system. The conditioner receiver exciter is going to be striped across 3 of these cards. We'll say, all right, maybe we're just taking in that much analog bandwidth that we need to, and that many channels that we just need an awful lot of hardware to be able to digitize all that. Then the next step in the chain is our signal object detector. Again, since we're dealing with so much data, it's going to be striped across those 3 cards to be able to handle all that bandwidth. At this point, the rest of the chain is going to be supported on these other two cards that are going to be running a container engine striped across them. All right, from here, after the signal object detector, the data has been decimated down enough that just the resources striped across two cards is going to be enough to run the signal and object characterizer. Same thing for the tracker. Now, thankfully for the situation assessor, the trackers neck down the data enough that we really only need one of the slices of those two to be able to implement it. And the impact assessor and responder can take up the other half. Now, the last piece that's necessary in order to get all this working is the hardware infrastructure to be able, including all the communication interfaces, switch interfaces, and clocking infrastructure to make all this work. So this is just a quick notional example of how a full-up processing chain could be implemented into a system with a set of hardware mappings. So in conclusion, right, SOSA is hoping to be able to be the basis for a very vibrant and diverse marketplace, which is going to be able to enable a lot of best of breed sourcing for our DoD acquirers. We're going to improve the life cycle and supportability of the products that are out there. And hopefully, due to the openness of the SOSA technical standard and the way that you'll be able to procure against it, hopefully this will allow for unknown opportunities for many different organizations, both on the DoD to discover unknown companies that have capabilities and companies that are able to pursue opportunities that they didn't know exist due to the openness that SOSA is going to enable. And then the sharing of the various capabilities and hardware and infrastructure between the various military branches, de-risking of product development. There's many upsides that we're hoping that SOSA is going to be able to bring to the ecosystem. So with that, I thank you for your time and your interest. I hope that that this presentation was able to give you a better understanding of what SOSA is about and how we're achieving our goals. And with that, thank you very much.
Excellent. That was an outstanding presentation from Nick Borton. And again, if you would like to learn more or have any questions for Nick, please utilize the chat facility in the lower right corner of our WebEx tool.